Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python, Part 7. In this lecture, I'm going to tell you how to succeed in this course. Let's start this lecture with a mini quiz, which I hope will be very easy. Question 1. Would you enter a boxing match without first learning how to box? The answer is, most likely not, since doing so would be very dangerous for you. Question 2. Would you attempt to fly an airplane without first taking flying lessons? The answer is, most likely not, since doing so would be even more dangerous. So what's the common theme here? It's that there are prerequisites to this course. The most proactive among you have already read the course description, understood what the prerequisites are, and taken steps to ensure that you are comfortable with those prerequisites. What should you do if you don't meet the prerequisites to this course? Well, you should stop right now. You will not succeed in this course unless you manage to learn the prerequisites simultaneously, which according to past students is an extremely difficult task. It depends how far behind you are. If you are only a few steps behind, then you may be able to catch up. But if you are so far behind that you can't write your own feed-forward neural network using the libraries we use in this course, then there's a lot of work for you to do. One common question is, why are the prerequisites not included in this course? This is because the prerequisites consist of multiple courses by themselves. For example, you can't take Calculus 3 before you take Calculus 2. You can't take Calculus 2 before you take Calculus 1. Another thing you might be wondering is, what are the prerequisites to this course? If you don't already know this, then you are already far behind. The prerequisites are listed in the course description. It is highly recommended that you always review the prerequisites for a course, no matter what course you're taking. The prerequisites for this course, at the bare minimum, are that you know how to build a feed-forward neural network in both Theano, TensorFlow, and pure NumPy. You should be able to derive backpropagation without any references. You should know calculus, linear algebra, and probability at the undergraduate level. If you got a C in calculus 20 years ago, this does not count. If you don't know these things, it indicates that you're lacking a lot of background knowledge that is essential to understanding what's in this course. These are really important, so if you have questions regarding how to learn these prerequisites or in what order, please post a question on the discussion board. I'm not bringing this up to discourage you, but rather this is from experience. Too many people end up not understanding the material because they didn't know about or decided to ignore the prerequisites. Sometimes people think I should have included those things in this course. The problem with this is, if I took everybody's opinion into account, this course would cover everything from at least 2 or 3 years of undergraduate study. So you're trying to take something that already takes very smart people 2 or 3 years to learn, and you're saying you want to learn it in 30 minutes. That's not very realistic. Moral of the story is, make sure you know the prerequisites, and make sure you're good at them. That probably means spending a considerable amount of time studying. For the coding portions of the class, realize that you shouldn't take the couch potato perspective in this course. You should think of my code as the answer or as a guide. In fact, you don't even need to watch the coding videos, since you can just look at the full code on GitHub. But it helps if you want to watch the coding proceed step by step. What you should be doing is taking the theory and going directly to code. This will force you to think in certain ways and ask specific questions. Only by trying to code directly from the theory yourself can you really learn this subject. Once you've attempted it yourself, you can look at my code and figure out what you were missing and why. Another thing people miss is that they don't ask questions. I've heard a lot of excuses as to why people can't ask questions using the discussion board. Usually people are just afraid that their questions are stupid. No question is too stupid for the discussion board. No one is judging you. Please ask your question. That's what it's there for. One thing you shouldn't do is give up at the first sign of error. Many people who are new to programming just don't know what it's like to be a programmer, or what it's like to take a real university-level programming course. If you expect things to work the first time you write it, you don't yet have a good sense of what it's really like to be a programmer. You should expect to spend hours, if not all night, or perhaps even multiple nights, getting things to work. This is where the real learning happens. If you're being spoon-fed answers, this leads to weak problem-solving abilities. Okay, so let's just reiterate that since it's very important. Spending hours or longer debugging and doing the derivations independently is when the real learning happens. Learning isn't the act of absorbing information. Learning is what happens when your understanding of the world changes. Don't aim to be spoon-fed answers, because this leads to weak problem-solving abilities. There is one more note to add here concerning practice. In my previous courses, getting more practice was apparently not quite straightforward. Oftentimes, people don't realize that there are tons of datasets out there for free. There are tons of datasets that researchers use as benchmarks, like the MNIST dataset and the CIFAR dataset. There's really no reason you can't download one of these datasets and apply the techniques you've learned. In this course, I've learned from my mistakes, and I'm explicitly telling you, get more practice by applying the algorithms you learn on different datasets. For this course, it's going to be especially easy. This is because if you've installed the OpenAI Gym, you already have tons of different environments ready for you to test. In this course, we're only looking at a very small subset of environments, but there's no reason you can't apply the algorithms you learn to different environments. Remember, OpenAI Gym makes this super easy because the interface to every environment is the same. You literally already have all the datasets on your computer, so I really hope at this point no one says to me that they need more practice, because I just told you how to practice. Some of these environments haven't even been solved yet, so if you get something working, then you are doing state-of-the-art research. In other words, these environments can keep you busy for years. There's nothing stopping you from applying these techniques to the environments you just downloaded. Another thing to mention is that in both my last reinforcement learning course and this course, I'm introducing you to many different types of algorithms, and these algorithms are not necessarily mutually exclusive. As you'll learn from this course, TD Lambda is an algorithm that unifies temporal difference learning and Monte Carlo. What I'm trying to get at is, there are a ton of different hyperparameters and combinations to try. You can modify learning rates, discount rates, lambda, epsilon, feature extraction, neural network architecture, and so on. The number of things you can modify grows exponentially. Remember, this is called the curse of dimensionality. You really cannot run out of things to try. So how do you succeed in this course? Write as much code by yourself as you can. There is a lot of code we won't write, since it would just be a combination of code we already wrote. Try as many hyperparameter settings as you can. Many hyperparameter settings just won't be able to solve the environments in the gym. In this way, deep learning is not as robust as we would hope. However, it means there's more practice opportunity there for you to try different things until your agent is able to learn to solve the environment.